Hello everyone. Now we have to discuss another type of parameters. Those are hybrid parameters, simply H parameters. So this type of parameters used in the representation of modeling of amplifiers. So modeling of electronic circuits. Okay. So here we can use both short circuit as well as open circuit terminal conditions. That's why this can be named as hybrid parameters. Why it is called as hybrid parameters? We are using short circuit as well as open circuited conditions of both, whether it is impedance or admittance. That's why these parameters are called as hybrid parameters. Okay, we can write the 2 points now. H parameter representation is widely used in modeling of electronic components, particularly modeling of transistor amplifiers. So you have clear-cut analysis in analog electronic circuits. There you have the application of hybrid parameters. Okay, means modeling of transistor amplifiers. That is, we can write common base, common emitter and transistor modeling. Right? Next point is what? So this, in this representation we have both short circuit as well as open circuit conditions, right? That is both short circuit and open circuit conditions are utilized hence this parameter representation is called as hybrid parameter, that is H parameter representation. Okay, so in the form of representation, in this form of representation, the voltage of the input port and the current of the output port are expressed because it is the combination of hybrid model of short circuit and open circuit conditions. That's why the output of the input port and the current of the output port are expressed in terms of current of the input port and the voltage of the output port. That is, now we can represent, see, the voltage of the input port V1 and the current of the output port I2, right, which are represented with what? H11, H12, H21, H22, right, which is equals to, here what we have, I1 V2. Now let's read this sentence. The voltage of the input port, that is V1, and the current of the, let us wait, the voltage of the input port V1 and the current of the output port I2 are expressed in terms of current of the input port and the voltage of the output port. Clear? Now from this, V1 which is equals to H11 I1 plus H12 V2, like that I2 which is equals to what? H21 I1 plus H22 V2. That's it. See, this part is what? This part is what? This is what? Voltage. This is what? Current, right? This is what? Current value. This is what? Voltage. Clear? See, this is voltage means what? We are using in this second part of the terms, we are using impedance conditions. The first part of this equation is uses what? Admittance conditions. That's why this is called hybrid presentation. Okay, what is the analysis now? Assume output port is short circuit, that is V2 is equals to 0. Okay, when V2 is equals to 0, V1 which is equals to H11 I1, like from this H11 is nothing but V1 by I1. This is first one. Second one is what? Like that I2 is equals to H21 I1, right? From this H21 is nothing but what? I2 by I1, right? Next, assume input port is open circuited, because the output port is what? Short circuit means what? We are dealing with what? Voltages. The initial part of this equation we are dealing with what? Current. That's why we have to open circuited this. Simple, we can write here. This part is open circuited, this part is nothing but short circuited. That's why they are here. Output port is nothing but short circuited. Now coming to this, input port is nothing but open circuited. Assume input port is open circuit, that is I1 which is equals to 0. Okay, now when I1 is equals to 0, what we have? Third one, V1 which is equals to H12 V2, right? From this H12 is nothing but V1 by V2. Fourth one, I2 which is equals to H22 V2. From this H22 is nothing but what? I2 by V2. So we have H11 V1 by I1, H21 I2 by I1 and H12 V1 by V2, H22 I2 by V2. Simply V1 I2, that's it. We have V1 I2, I1 V2. We have what? V1 which is equals to H11 I1, H12 V2. Here we have what? I2, H21 I1 plus H22 V2, right? So from this what we have? First one, by short circuiting output port, we have what? H11 V1 by I1, like that. H12 is nothing but what? From this H12 is nothing but what? V1 by V2. Next H21 which is nothing but what? I2 by I1. Fourth one H22 which is nothing but what? I2 by V2. See, from this we can write H11 is nothing but V1 by I1. V1 by I1 is nothing but what? Impedance, right? Voltage by current. Input impedance, that is input impedance. Clear? Now it is what? V1 by V2 is nothing but what? V1 by V2. Reverse voltage. This is constant value, that's why it is called as gain. Reverse voltage gain, like that. H21 is nothing but what? I2 by I1, that is forward current gain. So coming to H22, I2 by V2, current by voltage is nothing but what? Output admittance. Clear? Now what are the units? Input impedance, right? Ohms. This is unitless. This is also unitless because constant value, right? This is what? Mhos. Sorry, mhos. That's it. Now we have to get equivalent circuit. What is the equivalent circuit? This is what? This is voltage. This is current, right? This is application of KVL. This is the application of KCL. So you can do the analysis by using two previous methods. By using what? Impedance parameter and admittance parameter approach, we can have the equivalent circuit of hybrid parameters is what? Okay. First equation is application of KVL, right? That's it. Second equation is what? Application of KCL. Right? From this we have what? V1. This is V2. Input supply, output supply. The current through this is nothing but I1. I1. This is what? I2. This is I2. Clear? Now this is what? H11. See, H11 I1. H11 I1. Which is H12 V2. This is what? H12 V2. What is that value? That is voltage, right? That's why plus minus. Clear? This is what? Current source. H21 I1. This is H21 I1. This is what? H2. So this is voltage. This is current. See, this part is nothing but what? This part is nothing but impedance parameter equivalent circuit notation. This part is nothing but what? Admittance parameters equivalent circuit notation. That's why this H parameters is nothing but what? Hybrid parameters. Okay, this is about H parameter representation.